What's up guys, NishallTube here back with another video, and today we're going to be looking at what is a solution. This is a very important lesson for 9th grade chemistry, so stay tuned and watch till the end. Before we begin, don't forget to subscribe, like, and share this video with all your friends who might find this useful as well. Let's begin another NishallTube lesson, revolutionizing online learning. Alright, let's start with an introduction. What is a solution? A solution is a homogeneous mixture of two or more substances. Before we get in too far, what is a homogeneous mixture? What is a substance? What is a mixture? Let me clear all those questions for you. So, in our world, all matter occurs in either substances or mixture. A substance is the purest form of matter that occurs on this earth, while mixtures are a combination of two or more substances. So we got that part down. Substances either occur in elements or compounds, pure substances, and mixtures, most of the matter around us actually occur in the form of mixtures. So not much matter around us occurs in the form of a substance. So now what does homogeneous mean? For more help on homogeneous mixtures, it would be great to refer to a previous video on the separation of homogeneous mixtures, which I'll leave a link down below. But if you want a basic definition, a homogeneous mixture maintains uniform composition throughout, meaning that it looks the same and appears the same from top to bottom, as uniform composition. So that's what a solution is. The components of a solution are a solute and a solvent. We can think of it like an equation. A solute plus solvent is equal to solution. Typically, the solute occurs in smaller amounts while the solvent occurs in larger amounts. The solute is being dissolved in the solvent, and the solvent is dissolving the solute. So, to make sense of this, let's think of an example. Suppose we have sugar and water. In this case, sugar, which is most likely occurring in a smaller amount, would be the solute, and the solvent would be water, which is most likely occurring in a larger amount. On top of that, the sugar is being dissolved by the water. So, the solvent, which is water, is dissolving the solute, which is sugar. And the solute sugar is being dissolved in the solvent water. So I hope it makes sense now. Within solutions, we have a few different types, but the primary classification is aqueous and non-aqueous. Aqueous is in the name itself. Aqua means water. So in aqueous solutions, the solvent component is water. And in non-aqueous solutions, the solvent component is anything but water. So we can think of many examples for both. For aqueous solutions, salt and water, sugar and water, anything that involves water as a solvent. And for non-aqueous, we can take an example such as adding malt powder to milk to give it a chocolatey flavor. In this case, the solvent component is milk and not water, so it would be an appropriate example of non-aqueous solution. So, since the solution is a homogeneous mixture, it appears to be same throughout. It's also stable, meaning that if we leave it undisturbed for a period of time, the solute particles don't settle to the bottom. That's the meaning of stable. So now let's look at a few important properties. The properties are similar to the definition. So it's a homogeneous mixture of two or more substances. The particles are very small, almost less than a nanometer. So the particles of a solution are very, very small, almost less than a nanometer, which is equal to 10 to the power of -9 meters. Very, very small. The particles are obviously not visible to the naked eye, which is why it appears to be having a similar appearance throughout. The particles are too small to scatter a beam of light. We'll talk about the Tyndall effect, which is scattering a beam of light, very soon. So in other words, since the particles are too small to scatter a beam of light, it does not display the Tyndall effect. The Tyndall effect basically means that the particles of a solution, suspension, or a colloid are able to scatter the light particles and make the path of the light visible when it is shined through a glass containing that substance. And when left undisturbed, the solvent particles do not sink to the bottom, making it a stable solution. Now let's look at a couple types of solutions. We have 4: concentrated, dilute, saturated, and unsaturated. We'll look into each of these in depth. So concentrated and dilute are rather comparative terms. So we can say that sample A is more dilute than sample B, or sample A is more concentrated than sample B. Ideally, in a dilute solution, we're adding solvent, which is reducing the amount of solute. And in a concentrated solution, we're removing solvent, and ideally we're increasing the amount of solvent. So we can see this diagram here. In sample A, we just have a plain flask of water. In sample B, we're adding a small amount of copper sulfate, which is darkening the color and making it a little dilute. In sample C, we're adding even more, so comparatively, sample C, or flask C, is more concentrated than B. We can also say that B is more dilute than C. And eventually we add copper sulfate to its maximum amount which it can be dissolved to make it saturated. So that's what concentrated and dilute solutions are. So saturated and unsaturated. In a saturated solution, the maximum amount of solute has been dissolved in a solvent at a given temperature. So solubility is the measure of how much solute a specific solvent can dissolve at a given temperature. So we can see here in this diagram, at the saturated solution, no more solute can be dissolved because it reaches max solubility. And in an unsaturated solution, it hasn't reached its max capability, so more solute could still dissolve. We also have a supersaturated solution, meaning that some of the particles of the solvent cannot be dissolved and they just sink to the bottom and are clearly visible. So here are a few examples of a solution. You're looking at one right now. Salt water in the ocean. Lemonade and Coca-Cola. These are all examples of solutions. Next, suspension. A suspension is a heterogeneous mixture of two or more substances. The solute particles are suspended in the solvent, hence the name, suspension. The particles are clearly visible to the naked eye, and they're large enough to scatter a beam of light, meaning that they display the Tyndall effect. When you leave a suspension undisturbed for a while, the solute particles sink to the bottom, the suspension breaks, and we just see a lot of solute particles sinking to the bottom, meaning that it no longer displays the Tyndall effect. So a common question asked is, does a suspension display the Tyndall effect? And the correct answer would be only for a certain amount of time until the solute particles sink to the bottom. It's meaning that it's an unstable solution. So if the solute particles sink to the bottom after some time, that means that it's an unstable solution. A few examples of suspensions. I couldn't find the most appropriate picture to show a real life example, but flour in water, mud in water, chalk in water, etc. Next, colloids. A colloid is also a heterogeneous mixture, but it appears to be homogeneous due to the small particle size. Its components are dispersed phase and dispersing medium. Please note the typo. Dispersed phase and dispersing medium. Ideally, the dispersed phase is the solute type component and the dispersing medium is the solvent. The solute particles are dispersed evenly throughout the solvent, and these particles are not visible to the naked eye. However, unlike a solution, they're still large enough to scatter light particles. In other words, they display the Tyndall effect. It's also a stable solution, so if you leave it undisturbed for some time, the solute particles, they do not sink to the bottom. Common household examples of colloids are milk and smoke. Milk, the particles are evenly dispersed and they're small enough so that they're not visible to the naked eye. But in reality, these particles are still large enough to scatter a beam of light. So if we look at this in terms of particle size, the solution has the smallest particle size. It's less than the colloid, which is less than suspension. But however, the colloid and the colloid and the suspension display the Tyndall effect, which we'll be talking about right now. Alright. So, in a given circumstance, suppose we shine a beam of light through a clear glass containing a substance. This substance could either be a solute, a solvent, or a colloid. The Tyndall effect occurs when the particles of substance scatter the light. We'll be looking at that right now. So, suppose we shine a beam of light through a clear glass containing a substance which should either be a solute, a solution, a suspension, or a colloid. The Tyndall effect occurs when the particles of substance scatter the light. The scattering of the light particles makes the path of the light visible. So this Tyndall effect only applies to colloids and, as I mentioned earlier, suspensions to a temporary extent. So we can see this example here. This is our light source, and we have a solution, a colloid, and a suspension. When the light beam is shined through, we can see when it is shined through the solution, the path of the light is invisible. But when it's passed through the colloid and the suspension, the path of the light is clearly made visible. And this is the Tyndall effect. The Tyndall effect is the scattering of light by particles in a colloid or suspension. So it does not apply to a solution. No. So, thanks for watching. As always, don't forget to subscribe, like, and share this video to all your friends that might find this useful. We're trying to hit 100 subscribers as soon as possible, and I would be most definitely pleased if we hit this goal in the next couple of weeks. I'll be uploading a lot more videos during this time frame, so stay tuned. Keep learning and enjoy the learning journey. Until then, this is Nishal2 signing off. Peace.